Now, if you will see, this is C2. Okay, this is the mirror plane which contain the whole molecule. You see this. Okay, and this is the another mirror plane which is dissecting through the double bond. Okay, so how many symmetry element are present? One is E, another is C2, third one is sigma xz, and the fourth one is sigma yz. The same thing I have written: E, C2, sigma v, and sigma v dash. Sigma v dash is basically representing to sigma yz, always remember. Okay, so now the first strategy what we are going to apply is to find out the irreducible representation by applying the reduction formula. For that, I have told you that what you are supposed to find out, you are supposed to find out the unshifted atom during the symmetry operation. So let us see. For E, if you will see, right, in the process of E, what we will use to do, we will rotate the whole molecule with the angle of 360, right? So if I will rotate this whole molecule with the 360, how many number of atom will be unshifted? Anyone? It is already
Four.
been
Four.
four, right? I will tell you: one
Four, sir.
nitrogen, second nitrogen, third fluorine, and fourth fluorine. So total number of unshifted atom will be four. Even for the C2, if you will see, how many number of atom unshifted? If you will see, C2 means what? This axis, right? This one, red one I'm drawing. If you will rotate along with this, what would be happen? This NF will become here, and this NF part will come here. So in short, whole the molecule is going to be shifted. So the number of unshifted atom will be zero. Is that clear? Now
Yes, sir.
for the sigma v, I mean sigma xz, I have mentioned that number of unshifted atom is zero. Can anybody tell me why? How come the sigma v is zero?
So because the left side is the reflection of the right side.
Yeah, very good, very good. And then why sigma v dash is 4?
The molecular plane.
See, a sigma v dash corresponding to the plane which contains the whole molecule. Okay, this one I'm trying again. So if any mirror plane which is going to contain whole molecule, in that case the number of shifted atom will be zero, because everything will be as it is, right? So that's why I have mentioned 4. Good. Now this is the chi per atom. This is already fixed. I have already told you. For E you are supposed to write 3. For C2 it is minus 2 cos theta plus 1, right? So you put the formula, from that you are going to get it minus 1. Sigma v1 1. Then what we should supposed to find, we should supposed to find out the total number of mode. So in that case what we'll do, we will multiply both. This one, like 4 multiplied by 3, then 0 multiplied by minus 1, then 0 multiplied by 1, then 4 multiplied by 1. So that's what I have written is 4004. Okay, now what you will do, you are supposed to find out the reducible representation first. So this is the reducible representation 12002. Now you will apply reduction formula. From that reduction formula, I have put it directly here. You are able to get it 3a1 plus 2a2 plus 3b2. आपको क्या करना है? आपको याद होगा मैंने आपको बोला था 1 बाई h. h यहाँ पर कितना होगा? 4. E1 C2 1 sigma V1 sigma V dash 1. So order of the class is 4. So what we will write, 1 upon 4 in bracket 12 multiplied by irreducible representation. If you are taking A1, then you will write it 1 E1. Like this way you will solve and you will be able to get it. Later on we will see. Okay. I have not shown here the character table, otherwise I would have been asked. Now what we will do, in the previous work, if you will see, we are able to find out the total vibrational mode, right? In that vibrational mode, we do have bending as well as stretching, right? We are not able to find out which one mode belongs to stretching or bending mode. So the next step is we will move towards the stretching mode, that which A1 or B2 belongs to stretching or through bending mode. So what we'll do, for stretching mode, the basic thing, stretching activity used to happen through bond length. right? How many type of bond length are present in this molecule? Anyone can tell me? How many type of bonds are present in this molecule?
Three.
Three. How come three?
Two.
Yeah. If it is two, then tell me which one. हाँ बताए ना कौन से दो होंगे.
N single bond and N double bond.
Very good. Actually, two bonds will be there. One is NN double bond and another is NF. Three is not possible. Three, for stretching it is not possible. For IR we can understand. Okay. So if I will ask, the stretching vibration can be possible with two different mode, then what we will say across NN double bond, and second one is NF double bond. So what we will do, we will fix this first. Now see, earlier you have reduced the character table with respect to the number of atom. Here you will start with number of bond. Always remember, still we are not moving towards SALC. We are first finding out the stretching vibrations. So we are taking the priority for NN bond. Let us start. Now, if you will perform the symmetry element E, whether any change is going to be happen in NN double bond? I guess no. So number of unshifted bond, it will be 1. For the C2, if you are going to rotate, now see, in case of C2, mostly what we'll do, we will rotate through this direction. Am I right? So in that case, if you will see, what would be happen? This N will come here and this N will come here, right? But it is a story of atom, but now we are talking about bond. So don't think that this bond is going to be shifted. No, bond is not going to be shifted. The only variation which is going to see is along the atom, but here we are talking about the bond. That's why the C2 value will be 1 here. Is that clear? Now the third one is sigma V. Sigma V, again it will be 1 because the same story, the bond is not going to be shifted. Sigma V dash, since it contains whole molecule, so there is no point to discuss why it is 1. So this is, we have put it, the number of unshifted bond, that is 111. Okay. Now I have mentioned also here the NN stretching, the vector under C2 may appear to reverse onto itself, but in case of stretching vector, reversal of this kind are not counted as -1. Always remember why? Because whenever you are rotating this molecule through C2 axis, number of atoms are going to be shifted. Bond is not going to be shifted. So in that case, if you will put this regarding the reduction formula, means 1 by 4, 1 multiplied by 1, and A1, A2, B1, B2, if you will see, you will be able to get it. The NN straight bond will occur through A1 mode. Okay. See, I have not mentioned here the character table. Since already I have spent 3 lectures on this topic, so I'm assuming that this particular things you can done it by your own. That's why I'm directly writing A1. Okay. But still I would say that you go whenever you are going through, you better solve it and see to it whatever I have written, whether it is right or wrong. Okay. The next is the second bond length, that is NF. Okay. Now see what would be happen. So along the NF, if you will see through E, how many NF bond is going to be unshifted? Of course 2. Why? It is 360. So 1 and 2. Through C2, whether the NF bond is going to be unshifted or shifted. I have written 0, but can anybody tell me why it is 0? Hello? Hello?
So because C2 passes through the N and both they shift to opposite side.
Yeah, the whole bond is going to be shifted. Okay. Good. What about sigma V? Why it is 0?
So it is the mirror plane.
This sigma V belongs to which plane actually? Sigma XZ or sigma YZ? Or you can tell me whether it is passing.
Exit.
Exit.
Exit. Okay, good. And what about sigma V dash? Why it is 2?
Because it is
It
a
is the
molecular
molecular
plane.
plane.
Molecular plane. Okay, then. So I have used it here A1. A1 I have taken from character table. So I'm applying the reduction formula. Now see, what is the order of the class? 1, 2, 3, and 4. So that's why I have written 1 by 4. Then 1 belongs to symmetry element. E, how many E are there? 1. That's why I'm writing here 1. Then multiplied by the number of unshifted bond. Here it is 2. That's why I have written here 2. And during the symmetry operation, what is the value of E? It is 1. So you are writing 1. So 1 by 1 I have operated. For the next, if you will see, it is 1, then 0, 1. That's why I have written here 0. Now here 1, 0, 1. I have not mentioned here. It is again 0. The next is 1, 2, 1. 1, 2, 1. If you will solve it, it is going to get 1. So contribution used to become through A1, right? I told you that another way is that you will apply the same thing for remaining irreducible representation. For example, A2, B1, and B2. Another thing is that, see, you are having tau SNF, this one. So basically, this one belongs to what? This one belongs to the changes that is going to be occur in NF bond. So anything which is going to be occur through NF bond will give you the information that how many type of shifting are involved. For one way, you have find out the A. Okay. So what you can do, you can subtract through tau NF and you will get further another information, and that is B2. The other way around, in what way you can do? Don't go ahead with that. You better put it every value in the reduction formula for every irreducible representation, and then you will be find out. See, it all depends on you. I'm telling you to both way. In one way you can save your time, in another way you can be more precise and more, you will develop to understanding. I have mentioned both. In the first, I have put it in a formula. Then I get one mode, I get it, that is A1. For the second mode, what I have done, I have subtracted with the enough unshifted bond. Then I will get the information that will be B2, right? The second possibility is what you are supposed to do. You put it this value and apply the reduction formula like this way and get to know one by one that how many modes are involved. Now see, through NN bond, if I will talk, then it is A1. Through NF bond, if you will see, then it will be A1 plus B2. So total tau stretching will be 2A1 plus B2. One A1 is coming through NN bond. Okay. Now the next thing is we will find out through SALC equation for NF bond. Now see, this is I have shown you for the reference. Now see, the in SALC equation, what was the first strategy? You will bisect the molecule with respect to bond length. So what I have done, I have bisect this molecule, yeah, try to categorize it as S1, this one as S2. What is next? Now, if in your point group, suppose 2C3 is there, then in that case, you will write it as C3 and then C3 prime. But luckily in C2V point group, every symmetry element is single one. So there is a no point to bifurcate it. So I have written is C2V, E, C2, sigma V dash. Now what we will do, we will target with only one changes with one bond length, which is going to be changed. Now see, I am targeting with respect to S1. And this is mentioned in this square bracket S1. So what we are going to study, we are going to study the nature of changes which are going to be happen with respect to the S1. Okay. Now see, here with respect to symmetry element E, S1 is going to be changed? No, that's why we have written S1. Now, with respect to C2, if you will do, what will be happen? This S1 will come here as S2, right? So that's why I have written here S2. For the sigma V, again, this is the mirror plane, right? I will write this one. This is a plane, right? So in that case, again, S1 will be turned to S2. That's why S2. Sigma V dash is a molecular plane which contains the molecule. So in that case, no change. That's why I've mentioned as S1. Now, one by one, we will perform with A1. So it is 1, 1, 1, 1. Right? So in projection formula, I told you that what you will write 1 upon H, any order of the class 1, 2, 3, 4. So I have written is 1 by 4. Then you will multiply this. there will be no K. I already mentioned you. That's why I'm not using any symmetry element, number of symmetry element here. So 1 multiplied by S1, S1, 1 multiplied by S2, S2, 1 multiplied by S2, again S2, and 1 multiplied by S1, it is S1. So if you will see, if you will sort it out, how many S1? 2S1 plus 2S2. I have taken 2 as a common. So what would be when 2 upon 4, S1 plus S2. So I can say 1 by 2, S1 and S2. See, this 1 by 2 S1 and S2 means the projection operator gives you the information of 1 by 2 S1 S2. But whenever you are talking about SALC equation, in that case what you will write, you will take the square root of the coefficient of the symmetry, this one and this one. So before S1, what is the coefficient? 1. So 1 chi square plus 1 square. So it is root 2. That's why I have mentioned here root 2. Don't be get confused. If you want, you can write it as 1 by 2 S1, and second one is 1 by 2 this one. See, this much is used to become through projection. But if you want SALC equation, in that case, what is the real formula? In that case, you are supposed to take a root, and you are supposed to use the coefficient present before the S1. So what is the coefficient? That is 1 chi square. So like this way, plus again it is 1 square. So total what will be the value? It will be root 2. So 1 upon root 2, you will write it in a SALC equation, but project operation formula will give you the information, that is 1 by 2 S1. Okay, so this is the basic difference between projection operator and SALC equation. Okay, now the next. Through NF bond. Now see, in that case, if you will see, I have used now B2. Earlier I have used A1, now I am using B2. So in that case, if you will do, if you will come 1 by root 2 S1 minus S2. For this, I can tell you that it is 1, I will solve it. That is 1 upon 4 in bracket, it is S1, then what it will be, minus S2, then again it is minus S2, then it is S1. So if you will solve it, what it will be 2S1 minus 2S2. So again 1 by 2 S1 minus S2. But since I am writing SALC, that's why I am writing 1 by root 2 S1 minus S2. Is that clear? Now, how come it is minus S2? I can tell you, S2 multiplied by minus 1. S2 multiplied by minus 1. S1 multiplied by 1. That's why it is S1. Now, these are the modes I have shown it here. One is A1 mode. See, A1 is the most symmetric mode. So in that case, always remember the movement of the atom should be same. Now I have shown, I will tell you how to draw it also, but just listen here. See, this NF bond is moving in this direction. Okay. Now, if it is A1, then it means that another NF will also be moved in the same direction. Why? Because A1 is the most symmetric mode, and all the symmetry element present in this A1 mode will belongs to +1. It means everything should be same. So this way. Now, if the molecule is moving in this direction, then remaining molecule, to counter it, in which direction it will be moved? It will be moved in opposite direction. So this is the one representation of A1. Okay, now here I have shown that, see, this is asymmetric. Why? See, here this one is moving in this direction, but this one is moving in this direction. Okay, so this is asymmetric. Now it can be A2, it can be B2, but since you have find out that there is no A2 present, so it will be B2 only. But the motion of NN bond is in this direction. See, it all depends that which mode is less. Means suppose the movement along this bond is smaller in the magnitude, then of course what it will do, it will move in the opposite direction. If you will see the vector sum, then in what direction it is moving? It is moving in this direction, right? So NN bond will move always along the movement. So sorry, opposed to movement. So in that case, it will be move in this direction. So you are able to plot A1 as well as B2. Okay, for rest of the molecule, now you are supposed to find out. Now the third one is the SALC equation for another thing, that is bond angle, and it is bending mode. See, you may be able to know that the bending modes are generated due to in plane motion and out plane motion, right? So first we will start with in plane motion. How do you know that it is in plane motion? See, whenever any projection used double headed arrow, like this way, like this way, those correspond to in plane motion. And if it is single headed arrow, it means that it belongs to out of plane. Okay, so now I'm using double headed arrow, means we are going to discuss about the in plane motion. So how many angles are going to be projected? Two. One is going to F N N, another is N N F. I have categorized it at A1 and A2. So what we will first do, now we will first find out the symmetry element with respect to the NNF bond. Now see, with respect to E, it will be 2, because both are going to be unshifted. With respect to C2, of course, it is going to be changed. Sigma V change, sigma V dash is 2. Now I have applied it with respect to A1. If you will solve it, it will become 1 by root 2 A1 plus A2. With respect to B2, 1 by root 2 A1 minus A2. So what I can say, irreducible representation in plane is equal to what? 1 A1 and 1 B2. That's why I have written as A1 plus B2, but this is in plane motion. Okay, now here I have shown you the mode of representation. See, in plane of motion mein dekhe, both the fluorines, as I showed, if A1 is present, it means that both the NF will be moved in the same direction. See, both are in the same direction, these two. So with respect to that, N will always opposite. Since they are moving in this direction, so NN will move in opposite direction. In B2, I told you the motion, if you will see, actually this is with respect to angle, right? So in that case, this one is moving in this direction, whole, right? So as a result, NN will move in this direction. Remember one thing, whenever you are drafting this depiction with respect to the angle, with respect to the bond length, you should always think about that which is the deciding factor. Here the deciding factor is angle, that is theta, right? That's why you cannot write it ki F is also moving in this direction. You cannot write like this, like earlier we have written for stretching. This is wrong. Okay, so here of course you are talking about angle. So what you will do, the motion will be start through this way, no? So what it will be, this whole molecule is moving in this direction. And if you will talk about this way, so this whole molecule is moving like this way. So in short, if I will write the conclusive vector representation, so this is moving in this direction. That's why NN bond is moving in opposite directions. Okay, now the next. See, you have already find out the stretching. In the stretching, you have find out through NN bond, through NF bond, and just now you have calculated with respect to in plane motion. So if any vibrational changes or dipole movement changes are going to be happen, which is responsible for IR, what is remain, that is out of plane. So you know the total number of vibrations, you know stretching, you know bending. In the bending, you know the in plane. So it is very easy to calculate out plane. How do you calculate? What you will do, you will add everything. For example, you will add stretching, you will add bending, and you will subtract with total. So what you will get to know? You will get to know about the out of plane. Same thing I have done. See, you have already find out in the first slide this one, total number of vibrations. Then you find out with A1. Then you have find out stretching. Then you have find out in plane motion, right? The fourth one, which is out of plane. So what you can do, you can add these three and you can subtract with this one, then you will get to know about the out of plane. This is the one way. Another way I will tell you. Now see, again you will depict it. So if you will see here, this is out of plane. Why? This is fluorine. This both the fluorine. See, one is gray color part, this one belongs to plane. Now this dark, right, this one belongs the motion out of the plane, And another beautiful thing is that out of plane is clear because both the fluorines movement is going to be depicted with single headed arrow. It means it is out of plane motion. Now if you will see with respect to E, of course both are going to be same, that's why I have written 2. For C2, if you will rotate, everything is going to be changed, then 0. Sigma V minus 2. Sigma V bar is minus 2. Can anybody tell me why it is minus 2? Abhishek?
Yes, sir.
Yeah, any idea
No, sir.
why it is minus 2? And you should ask no. Anyone else in the class who can respond it why it is minus 2? Why not it is plus 2?
बिकॉज वो मॉलिक्यूलर प्लेन के बाहर है, मतलब उसका डायरेक्शन
हाँ,
चेंज होगा, इसीलिए वो मतलब वो आउट ऑफ द प्लेन जा रहा है ना.
which one is going to be out of the plane? Can you tell me B1 or B2
सर
or
दोनों
both?
ना, दोनों.
हाँ, बराबर बराबर. मैं अभी आपका नाम नहीं देख पा रहा हूँ, कौन बोल रहा है अभी?
उर्मी.
Urmi, very nice Urmi. See, I will tell you why minus 2. See, what is sigma V bar? Sigma V bar is basically a plane which contains the whole molecule. Okay, if you are taking whole molecule here, you are putting a mirror below this molecule. What would be happen? This B1 which is projecting up head, this B1 up head, this B2 up head. If you will put the mirror, what would be happen? They will start to move in this direction. Is it I'm right? So in that case, direction is going to be changed. It is upside, now it is downside. So it will contribute minus 1 and this one also correspond to minus 1. So total it will belongs to minus 2. Is that clear? Urmi, yahi tha aapka answer bhi?
यस सर.
Okay then. Okay, so again the same story. We are going to implement on every reducible representation. I have written here only A2. Because A1 के केस में 0 आ रहा है, but you can do it at your home. So I have taken this whole line from character table, that is 1 1 1 minus 1. Now we will operate. What would be we will written 1 2 1, same here 1 2 1, then 1 0 1, so 0, then it is 1 0 minus 1, again it is 0, then 1 minus 2 1 minus 1, right? So if you will sort it out, it will be A1. Again I will repeat, whether you want to perform on every reducible representation, it is of your choice, that is also correct, but I want to use some shorthand. That's why what I have done, I have subtracted this A1 with the total, sorry A1 nahi, A2. So in that case I have subtracted and I come across with the B1. See, no need to subtract this whole from this. If you will subtract 2 minus 1, what will become? It will be 1. So it is 1. Now 0 minus 1, so it is minus 1. 0 minus 1, क्योंकि subtract कर रहे हैं, so it will be plus 1. So minus 2 minus minus 1, so it means minus 2 plus 1, so it is minus 1. So what is your next job? You will see that these characters are coming under which irreducible representation. So since I have already evaluated, so it is coming B1, so I am writing directly as a B1. Okay, so this is the one way. Another way is that if you don't want to go ahead with this way, the best thing is that you apply on all 4 irreducible representation and you will come across that which one is present, which one is not. So here we are able to find out A2 plus B1. Okay, now the next is SALC equation for this. For the SALC, you know, we have to first specify that on which vector we are going to apply. So our is always first, this is B1. Right now, if you will apply on E, so anything which is not going to be changed, so you will write it as B1. Now, if you will through apply C2, C2 क्या है ये? You are going to rotate this. What would be happen actually? Why it is minus B2? Abhishek?
हाँ सर, वो प्लेन के बाहर जा रहा है ना सर.
अरे तो B2 होना चाहिए यार.
It is C2, no?
No, that is okay. I'm asking in case of C2, if you will see here, it is showing minus B2. Why? It should be B2, no? C2 में क्या होगा? B1 is going to become here, so it should be B2. उर्मी,
सर आपका क्वेश्चन ही नहीं समझा.
मैं ये बोल रहा हूँ C2 सिमेट्री एलिमेंट में जब हम प्रोजेक्शन फार्मूला लगा रहे हैं तो यहाँ पर देखिए मैंने लिखा है -B2, राइट? Why it is -B2? It should be B2, no?
Why B2? But it should be B2.
But why I have used minus? I have written minus, right?
Because वो
Minus
वापस
B2.
प्लेन ही है ना.
नहीं. If you will perform B2, if you will perform C2, B1 will come in this position, but always remember it will come in this direction. Opposite.
हाँ हाँ.
बराबर है ना? Clear है? That's why I'm writing -B2, right? Now the sigma V it is B2. Why? Because sigma V क्या है? ये है. So what would be happen? Shift होगा. B1 यहाँ पर आ रहा है B2. That's why I have written B2. But sigma V dash again you will remember it is -B1. Be careful with minus. So sigma V dash क्या है? This is the whole plane which contains this molecule. So in that case, if you will put the mirror below side of this molecule, what would be happen? B1 will be again come in this direction. That's why I have written -B2. I have prefer A2. Okay. So A2 I have taken from character table. Now you operate it. 1B1, this is 1B1 minus B2 minus B2 and then plus B1. Same thing I have written. B1, if you will multiply B1 with 1, what would be happen? It will be B1 minus B2 1, so minus B2. B2 multiplied by -1, what would be? Minus B2 and then minus B1 minus 1, so it is B1. Okay, the number of order of the class always fixed, that is 1/4. If you will sort it out, it will be again 2/4, so it will be 1/2. In terms of SALC, if you will write, you will take the square root of it, so it is 1/√2. This is the depiction I have shown here. See, in that case I have shown, since it is A2, this 2 means with respect to the C2 axis the value will be -1. Sigma V के respect to -1, right? So it cannot be same. So that's why this whole depiction is not right for this. So in that case, we have taken it like this way. Side by side, always try to learn the depiction also. Okay. So I will again repeat it. This is the basic thing I have applied where like I have taken, okay, B1 and B2 will be like this. But this depiction does not belongs to A2. Why? Because this belongs to A1. If you will see, both B1, both are moving in the same direction. The things are moving towards symmetric, but you are getting the answer A2. So in case of A2, 2 belongs to what? With respect to symmetry element sigma V, it is -1. Means there is one thing which is not symmetrical, yeah, which is not same as earlier. So simple changes with respect to B2, you can write it here. And this is a depiction. Now, I will summarize the whole thing. So if I will summarize, then total vibration mode you have calculated with respect to 3A1 plus A2 plus 2B2. This is from first slide. Then you have find out with respect to NN bond, that was A1. Then with respect to NF, you find out this is A1 plus B2. With respect to in plane, it is A1 plus B2 and remaining is out of the plane, that is A2. So this is the whole information. If you will see the IR spectra of N2F2 molecule,